Well, welcome to the new lecture. I'm calling it new lecture number 18 because we are now shifting our focus into optical instruments. Now, when you are shifting our focus into optical instruments, the first instrument that comes to our mind is the microscope. Have you seen a microscope? You must have seen a microscope. What does a microscope do? And if you have small things that you cannot see with your naked eye, very small to see, you put it inside a microscope, beneath a microscope, and you see an enlarged view of the same. Now, how does a microscope function? Let me ask you, how does a microscope function? Now, obviously, the microscope that you are going to use in your lab or in your hospital are very complicated things. Not very complicated. This is combination of different lenses. You might have seen all these different lenses. You rotate around with the lenses. Different lenses will give you different perspective of the same scenario. Now, if we talk about microscope, obviously we are not going into much detail. We are going to just study the simple principle on which a microscope works. Now, what does a microscope do? If I ask you very simply, what does a microscope do? The answer is very simple. If you have small things, very small thing, it enlarges the image of those small things. So far, so good. How does it do it? That is the question. Now, if there is a question, there has to be an answer. How can something or some instrument enlarge a small body? What are your ideas? Don't have a microphone, so you cannot share your ideas. But let us go back and think about a convex lens. Now, a convex lens, it can give real image of a real object. Now, this real image for this real object can be small, diminished. It can be of the same size. It can be bigger than the object itself. Do we remember this? A convex lens, a simple convex lens. It can form real image of an object, real object. It can be diminished. It can be of the same size. It can be larger than the object. Do you remember this? Can I have some raise hand that we remember this? On the other hand, if I talk about the virtual image that this produces, it can only produce virtual image of a real object. It cannot produce virtual image of a virtual object. Now, whenever a convex lens produces a virtual image, if I may ask you, the position of the object is always between the focus and the pole. Do we remember it? For a convex lens to produce a virtual image, the position of the object must be between focus and the pole. Do we remember this? Yes or no? Now, whenever this virtual image is produced by a convex lens, it is always enlarged. Do we remember it? If you remember it, great, because that is the exact concept of a microscope. And to understand this concept, what we are going to do is we are going to do a very simple microscope, which is also known as a simple microscope. And what does this simple microscope consist of? Well, you might have seen it in movies, in olden movies, where you used to have a detective. He used to have a simple lens, and if there is small words written, he uses this lens, and he sees these words getting bigger and bigger. In fact, if I remember in some of the comic movies, I think that Hera Fairy and all that, this Paresh Rawal character, he keeps this convex lens, and he sees smaller letters getting bigger. My eyesight is also getting weak. I can't read small letters, so probably I will have to use a microscope. I will have to use a lens to see all this. Now, what does a simple microscope do? Now, simple microscope basically consists of what? You can see here, this is a simple microscope. I hope you can see it on the bigger screen. Yes or no? This is a simple microscope, and what it is consists of? It simply consists of a convex lens. Do we understand this? A simple microscope simply consists of a convex lens. Now remember, this is the focal point of this convex lens. The object is placed between the focus and the pole. Do we see this? Yes or no? Whenever the object is placed between the focus and the pole of a convex lens, it will always produce a virtual image. This is the virtual image, and this virtual image is always enlarged. And this, gentlemen, a simple convex lens is known as a simple microscope, and the position of the object is between the focus and the optical center, and it will produce a virtual, magnified, and erect image of the object. Do we understand this? Yes or no? So what are the things that you must remember about a simple microscope? Point number one, it is nothing but a convex lens. Point number two, it will always produce a virtual and an enlarged image. But it will only produce a virtual and an enlarged image when the object is between the focus and the optical center. And therefore, to produce a simple microscope, we need a lens which has a very large focal length, so that whatever the object always lies between focus and the pole of the lens. Do we understand this? If the focal length is smaller, what will happen? If the object goes beyond the focus, then you will start to get diminished images as well. We understand this? That is why we need, for a simple microscope, we need a convex lens with a large focal length. Can you write this down? I'll give you a minute to note it down. A minute to win it. Let's move ahead. Diagram number one and diagram number two. In diagram number one, there are some terms that you must understand. The first term is h. What is h? H is the height of the object or the size of the object that you are seeing. D, capital D, and we'll come across this capital D many a times. Do you know what is this capital D? Sometimes it is known as near point. It is the least distance of distinct vision. Have you heard this? Least distance of distinct vision. This is the least distance where you can see, where your eyes can see an object clearly. Do we know this? Yes or no? It's normally around 25 centimeters. Do you know this? Yes or no? Okay. Now, first thing is h is the height of the object. The second thing is least distance of distinct vision. And you can see this angle alpha. This angle alpha is nothing but the angle this object has at your eye. So this alpha, this angle alpha, or tan of this angle alpha, if I write the value of tan of this angle alpha, and if this angle alpha is very small, the tan of the angle alpha will be equal to the angle alpha itself. Remember, when the angle is very small, tan alpha is equal to sin alpha is equal to alpha. Do we know this? Yes or no? Now, this tan of alpha, which is also, you can call it as alpha because the angle is very small, will be written as perpendicular divided by base. I will just remove this one. Perpendicular divided by base. Perpendicular is h, base is d. Do we understand this? So tan alpha becomes h by d. Can I have some raised hand that we understand this? Now, if I write it in sign convention, because we have to use sign convention, this d will be in the negative direction. It will become minus d. Anyway, let us come to figure number 2. Now, what is there that you got to see in figure number 2? In figure number 2, this is your image. The image is enlarged. The image is formed at a distance v. The object is placed at a distance u. H is the height of the object. F is the focus or the focal length of this convex lens. Now, can you see this angle beta, everyone? Can you see this angle beta? This angle beta is the angle subtended by the object at the lens. If I ask you the value of tan of beta, if I ask you the value of tan of beta, which will be equal to beta because this angle is very small. Can you tell me, bacha, what will be the angle? What will be the value of tan beta or beta? Simply perpendicular divided by base. Perpendicular here is h, base here is u, which is the object distance. Yes or no? Do you understand this? So these are the two things that you must remember. Value of tan alpha, h by d, value of tan beta, h by u, and you must draw it in your diagrams. I'll give you a minute to do this. It's very essential that you understand this because everything depends on your understanding of this. If it is clear, I'm sure there is going to be one question from this optical instruments, a very simple one, may not be so complicated, a very simple one. But if you understand microscope, telescope, you might not get a question. But microscope, there's a high probability that you get a question. I'll give you a minute to note all these things down in your sheet. I hope you are doing it. Have you noted it down? Okay, I'll give you more time. Have you done, bacha? Okay. Then, as I told you, most of the questions that you will find in this particular topic will be based on theory and hardly expect any numerical. If the numerical is there, it will be based on a simple formula. Now, whenever you ask about any optical instrument, apart from understanding how it works, what you got to understand and what they will ask is the magnifying power, because this is what the optical instrument is for. It has to magnify things. Microscope has to magnify things. If it doesn't magnify things, it is of no use. Magnifying power is the most important aspect. Now you also must remember how this magnifying power is defined for a simple microscope, because for different instruments, the magnifying power is defined slightly differently. So please mark this as star. Magnifying power of a simple microscope is the visual angle at the instrument beta. I have told you the value of tan beta divided by the maximum visual angle for the unaided eye alpha. So it is nothing but beta divided by alpha. Why it is like that? This only tells us that how much this instrument is going to magnify the object. It is beta divided by alpha. Beta is h by u. With sign convention, it becomes h by minus u. Alpha is h by d. With sign convention, it becomes h by minus d. When you divide these two things, this is the magnifying power or small m for a simple microscope. The formula is simply d by u. Do we understand this? The formula for magnifying power of a simple microscope, which is a convex lens, is d by u. Now, whenever we talk about these optical instruments, we have to consider two cases. Case number one, again I'm marking it to the star, is when the image is formed at infinity. Case number two, when the image is formed at least distance of distinct vision, capital D. Now in both the cases, the magnifying power is D by U, but depending on where the object is placed, the formula changes for case number one and case number two. When the image is formed at infinity beta, when the image is formed at infinity beta, when the image is formed at infinity, the object must be placed at the focal length, and therefore the formula, instead of d by u, remember d by u is the original formula. In this case, d by u becomes equal to f. The formula for image at infinity, magnification formula for this convex lens or the simple microscope, instead of d by u, you can also call it d by f. Do we understand this? Similarly, when the image is formed at the least distance of distinct vision, what we got to do, as you can see, just find the value of d by u. In this case, the value of d by u will come as 1 plus d by f, and this is the simplest form in which you can remember this. For image formed at infinity, the magnifying power is d by f. It is always d by u, but u becomes equal to f. For image formed at infinity, the magnifying power of a simple microscope is d by f. When the image is formed at least distance of distinct vision d, the formula becomes 1 plus d by f. So the only difference between the two formula or two formulae is the value of this 1. So in case of least distance of distinct vision, it becomes 1 plus d by f. In case of infinity, it becomes d by f. Do we understand this? Remember, the original formula is d by u, whether it is here or it is here. The only thing is the value of d by u becomes different in both the cases. In first case, infinity wala case, d by u becomes d by f. In second case, least distance of distinct vision, d by u becomes 1 plus d by f. Very important point that you must remember. I'll give you a minute to note it down. And this is a simple question that comes just for you to revise. And I'm expecting an answer. In a simple microscope, if the final image is located at infinity, what is the magnifying power of that simple microscope? A, B, C, D options are there. Can you tell me which is the correct option? 1, 2, 3, 4. Which is the correct option? A simple microscope. Final image is formed at infinity. What is the magnifying power? What is the answer? One, two, three, four. What is the answer? One, two, three, four. One, two, three, four. What is the answer? Remember, it is always equal to d by f. If the image is formed at infinity, the value of d, least distance of distinct vision, is 25. Do we remember this? Do we know this? Yes or no? So the answer in this case becomes option A, or 125 by f. Do we understand this? So the answer is 25 by f in this case. Simple microscope, it basically consists of one lens, which is a convex lens. But obviously, simple microscope is not going to solve much of the purpose. We need a more comprehensive one where you can have more settings, you can have more lenses, and you can see the images, same image in different perspective. And therefore, we have the second type of microscope, which is known as a compound microscope. Now, you will have to draw this diagram, and I'll give you time because we'll be probably discussing it in the next class. Now, just to give you a view of what is there in a compound microscope, I hope you are going to write the heading as compound microscope. So please write the heading as compound microscope first. First things first, write the heading as compound microscope, and then everything about this microscope that you have to understand is in the diagram. So we'll have to study the diagram carefully, and I'm going to show you on the bigger screen the diagram so that we can understand the working of this microscope and draw the diagram so that we can continue with this diagram in the next class. Now, what is the difference that you see in this microscope and the previous one that you saw? Do you see some difference? Yes, the most obvious difference is instead of having one convex lens, it has two convex lens. You can see this one is a bit smaller in size. This one is a bit larger in size. There's a reason why this is so. Okay. This first lens is known as the objective or the object lens. Why it is known as the objective or the object lens? Because it is nearer to the object. I hope you know this terminology. The second lens, which is closer to your eye, is known as the eye lens. I hope you know this. Yes or no? Yes or no? Okay. The first lens, and this is the object. And remember the position of the object, it is beyond the focal length of the objective, FO. Because if it is between F focal length and the pole, the image will be virtual, which will be created by this objective lens. We do not want a virtual image. We want a real image. This real image which is formed is inverted, and VO is the distance of the first image that is created by the objective lens. So far, so good. Are we following this? Yes or no? A is the object. H is the height of the object. The object is placed beyond the focus of the first lens. The object distance is U0, not standing, or 0 standing, or O standing for the objective lens. FO is the focal length of the objective lens. VO is the position of the image or distance of the image from the objective lens. Then we have the eyepiece. Now this object, this image which is created by this first lens acts as an object for the second lens, which is our eyepiece. So this is UE, the distance of the object, the new object from the eyepiece, and this is VE, the distance of the image, final image from the eyepiece, and it is formed at the least distance of distinct vision. H2 is the final height of the object. As you can see, the initial height of the object was very small. The final height of the object is very large. That means we have done one thing very clearly. We have enlarged the object a lot more. When we were using a simple microscope, only one lens, we were not able to enlarge the object very much. But here, as you can see, we have enlarged the object to a very large extent. Do we see this? Yes or no? I will urge you to draw this diagram. This is very important. You may not draw this eye. So complicated for you to draw this eye, but you will have to draw all the other things that I have marked and mark them clearly. H is the height of the original object. H1 is the height of the image formed by the first object. H2 is the height of the final image formed by the eyepiece. Is it clear to everyone? The diagram is very important. I'll give you time to draw the diagram. Your time starts now. Then let's proceed. I will just give you a brief description of what has happened. I've already told you, but just go through what is happening. A compound microscope basically consists of two lenses and it gets a more magnified image of the object. The object is placed in front of an objective lens and image is seen through the eyepiece. Remember this. Object is in front of the objective and image is seen to the eyepiece. The next very important point is the aperture or the focal length of the objective lens. Remember, objective lens is small, eyepiece is bigger. The aperture of the objective is very less as compared to the eyepiece because object is very nearer. So the objective lens is very small and the eyepiece is very large. This is one important point that you must remember. Objective is small, eyepiece is large. Now what is the place where object is placed? Remember, all these points will come. Object is placed between F and 2F of the objective lens, between the focus and the 2 times of focus. It creates a real inverted and magnified image of the object. So the first lens objective, the object is here, it will create an inverted image which will be enlarged. This is known as the intermediate image A dash B dash. I told you H1 is the height of this image. The intermediate image acts as an object for the eyepiece. Now the distance between both the lenses are adjusted in such a way that the intermediate image falls between optical center of eyepiece and its focus. So whenever you are setting this microscopic lens, the first image would be set in such a way. The first image, please note this point. The first image will be set in such a way that it lies between the optical center and the focus. So what will it do? It will create a virtual, inverted, and a more magnified image of the object. So magnification increases tremendously. Do we understand this? This is how a compound microscope works, and this is what you adjust. In a microscope, you are adjusting the length of the tube. You call it the length of the tube of the microscope. We will get to know about this length of the tube. I'm finishing this class here with by giving you a overview of what is a microscope. Remember what we have done in this particular lecture, because this lecture is going to continue. We have seen what is a simple microscope. A simple microscope is nothing but a simple convex lens. The simple convex lens, when the object is placed between the focus and the pole, we will see virtual and enlarged image, but the magnification is not that much. To have more magnification, what we do, we make a compound microscope which has two lenses. One is known as the objective, smaller lens, smaller focal length. The other one is known as eyepiece, larger lens, larger focal length. Now this objective will create a real inverted and enlarged image. For that to happen, object has to be placed between f and 2f. This image will act as an object for the eyepiece, and we will adjust the lens in such a way that this image, first image, will lie between the center and the focus, so that the final image that you get is more enlarged, is inverted, and it is virtual. And this is how a compound microscope will give you much larger magnification as compared to a simple microscope. We'll understand about its magnification and its magnification power. Again, there will be two cases here. Case number one, image is formed at infinity. Case number two, image is formed at least distance of distinct vision. So what I will suggest is, if you can go through the theory which is already given into a sheet, and it starts from page number 41, you can just go through this page number 41 on your own for a combined microscope. That will give you a much good perspective, and we can probably finish with microscopes and telescope in the next class. I want to wind up this chapter in the next class. So we would be working on to getting this thing done by the next class, because we also have to deal with defect of eyes. So I'll try to do it in the next class. I hope you have loved this class. Go through the compound microscope once again. I'll again give you a recap in the class tomorrow. Draw the diagram and come back. See you tomorrow. Take care. Have a nice day, beta.